Hello friends, this is Infinity Vision. Myself Gurleen Singh, and I'll be discussing relations and functions, exercise 1.4 solutions. Now this exercise is mainly about binary operations. Okay, so let's see what type of questions do we get in this exercise, and we'll try to solve them one by one. Now the question, let's try to understand the question. Determine whether or not each of the definition of star, this is the binary operation, given below gives a binary operation. Now this star, we have to show in which of these star it represents a binary operation. In the event that star is not a binary operation, give justification for this. So let's see for the first case. So we have on Z plus, define star by A star B as A minus B. So let's take an example 1, 2. Now this is an ordered pair A, B, 1, 2, right? What is 1 star 2? This is equal to 1 minus 2, which is minus 1, right? Now this is defined on Z plus, right? But a number which our answer is coming, this is coming in Z minus, right? This minus 1 is coming in Z minus. So the image is coming in negative numbers. So therefore, this is not a binary operation. So that's how we check whether each star is a binary operation or not. Okay? We take examples, or if we can prove otherwise, we'll see that way. So let's see second example. A star B is equal to AB. Now this is very simple. If we have Z plus A star B is equal to AB, for AB belongs to Z plus, there exists AB also in Z plus. Since if A and B are in Z plus, AB, the product of these two numbers, will also be in Z plus, right? So therefore, this is a binary operation. So what we have to prove is that if individual numbers belong in Z plus, then this operation, this star, this value should also belong in that same Z plus. So the next one is A star B is AB square. Now for this case, we can simply see that for A belongs to R and B belongs to R, there will exist a unique AB square which will also belongs to R, right? So therefore this is also a binary operation. Sorry. Similarly for Z plus A star B is equal to mod of A minus B. Now in this case, we have mod of A minus B. Now if both numbers belong in Z plus, right, even if we have B greater than A, let's suppose we take an example 1, 2. Now what is 1 minus 2? This is equal to minus 1, but the modulus will come out to be 1. So this will also lie in Z plus. So therefore this is also a binary operation. And let's see the fifth question. A star B is equal to A. Now this is also very simple. If A and B both belong to Z plus, this will also belong to Z plus. Since A belongs to Z plus, the answer A will also belongs to Z plus. So that's how we see whether this star is a binary operation or not. So moving on, let's see the next question. For each operation star defined below, determine whether star is binary, commutative, or associative. Okay. Now in each case we have to check whether this operation is binary operation or not. Okay, and in the next case we have to check whether it is commutative or not, right? So this is defined on Z. Now the difference between this one and the last question was that in that case we had Z plus, but in this case we have Z. So A star B will also lie in Z. So therefore this will be binary for sure. Now we have to see whether this is commutative or not. Let's take an example, 1 star 2. What is this value? -1. And what is 2 star 1? This value is 2 minus 1. So 1 star 2 is not equal to 2 star 1. Therefore, this is not commutative. Right? And now let's check for associative property. Let's say we have 1 star 2 star 3. Let's start with this. We have 1 minus 2 star 3 minus 1 star 3 minus 4. And if we take 1, sorry, the bracket will not come here. The bracket will be here. 1 star 2 star 3. In this case we get 1 star 2 minus 3 1 minus 1. So this will come out to be 2. So therefore these two are not equal, right? So this is not associative as well. So this is how we show whether this operation is commutative or not and whether it is associative or not. So let's clear the screen and see the second part. So second part is also a binary operation. A star B is equal to AB plus 1. So let's take A star B and let's take B star A. What are both the values? This is AB plus 1. This is BA plus 1. Both are same. So this is commutative for sure. Right? Now let's check A star B star C. Now this is equal to AB plus 1 star C. Now what will be this value? This value will be AB plus 1 C plus 1. Since we are just multiplying these two numbers and getting the answer. So this is ABC plus C plus 1. And what is A star B star C? So B star C is BC plus 1. So this is A star BC plus 1. Right? And this will be equal to A times BC plus 1 plus 1. ABC plus A plus 1. Now this was ABC plus C plus 1. This is ABC plus A plus 1. So this is not associative. Right? Commutative it will be, but this is not associative. Moving on to the next part. A star B is AB by 2. So let's see this one. What is A star B? AB by 2. What is B star A? BA by 2. Is there any difference? No. It's actually the same thing. So the commutative property will be satisfied. What is A star B star C? This is equal to AB by 2 star C, which is ABC by 4. Right? It's pretty simple to calculate. A star B is AB by 2. Now we have AB by 2 star C. So it will be AB by 2 times C divided by 2. Right? And if we take A star B star C, this is equal to A star BC by 2, which is A times BC by 2 divided by 2 ABC by 4. So associative property, it's satisfying. So this is both commutative and associative. Let's see the next problem. 2 to the power AB. Okay, so let's take an example 1 comma 2. Okay, so we get 1 star 2. This is equal to 2 to the power 2 4. So this is pretty simple. What is 2 star 1? It will be the same thing. 2 to the power 2 into 1, 2 square is equal to 4. So this is commutative for sure. Okay. Now let's see associative property. So now we take 1, 2, 3. 3 numbers. So first we take 1 star 2 star 3. So what is this value? This value is 2 to the power 2 star 3. 4 star 3. 2 to the power 12. So this is the first value. If we take 1 star 2 star 3, what is 2 star 3? This is 2 to the power 6. And what is 1 star 2 to the power 6? What is actually 2 to the power 6? This 64. So this is 2 to the power 64. So these two are not equal. So therefore associative property will not be satisfied. Okay. Moving on to the next one. Fifth is A star B is equal to A to the power B. Okay. So what is B star A? B to the power A. So these two are not equal. So therefore this is not commutative, right? Now let's see 1 star 2 star 3. What is this value? This is 1 to the power 2 star 3, right? 1 star 3, 1 to the power 3 is equal to 1. What is 1 star 2 star 3? So this is equal to 1 times 2 to the power 3, 1 star 8, 1 to the power 8 is equal to 1. So in this case, this is getting satisfied, but will this satisfy for all the cases? Are you sure? Now if we take case 2, 3, 4, the result will be different. It is satisfying for one, so the lesson from here is you can't rely on just one case. You can't just check one case and say that this is commutative or associative or not. When you're taking examples, in case of examples, you have to show otherwise. Or you can just simply say, if you have A star, B star C, this is nothing but A to the power B star C, which is nothing but A to the power B to the power C, which is nothing but A to the power BC, right? If we take A star B star C. This is A star B to the power C, which is A to the power B to the power C. So there's a difference between these two. This is A to the power BC, this is A to the power B to the power C, right? So that's the difference. So therefore, this is not associative. Okay, let's see the last example now. A star B is equal to A upon B plus 1. So what is B star A? B upon A plus 1. So this is not commutative since these two are not equal. Okay. Similarly, can you prove that these are not associative as well? What is 1 star 2 star 3? This is 1 by 3 star 3, which is 1 by 12. Okay. And what is 1 star 2 star 3? This is 1 star. What is 2 star 3? 2 by 4. And what is 1 star 1 by 2? So the answer will be 2 by 3. So this is not associative as well. So it's pretty simple to see that if a binary operation or if a just an operation is not commutative, it will not be associative in most of the cases, right? But if it is commutative, it may or may not be associative. In binary operations, it usually happens. Okay? So the next question is, consider the binary operation on the set 1, 2, 3, 4, 5 defined by A operation B is equal to minimum of AB. Write the operation table for operation, this one. So how do we make operation tables here? Let's see. So for operation tables, we first write down all the values starting from 1 to 5. So this is 1, 2, 3, 4, 5. Similarly, this is 1, 2, 3, 4, 5. And this is the operation which says minimum of A and B. So now we start filling the table. How do we start filling the table? This is 1 and 1. What is minimum of 1 and 1? It will be 1. What is minimum of 1 and 2? This will be 1. So for all elements in this column, answer will be 1. 1, 1, 1. Since the minimum value from here will be 1. From 2 and 1, it will be 1. From 3 and 1, 1. Similarly, for all these, except the first one, for 2 and 1, it will be 1. For 2 and 2, it will be 2. For 2 and 3, minimum will be 2. Again, fill just 2, 2. For here, between 3 and 1, minimum will be 1. Okay. 3 and 2, minimum will be 2. Okay. 3 and 3, minimum will be 3. And for the next, minimum will be 3. Similarly for next, for between 4 and 1, minimum is 1. Between 4 and 2, minimum is 2. Between 3 and 4, minimum is 3. Between 4 and 4, 4. And between 4 and 5, 5. Similarly, last one will be this. So this is the operation table for this operation minimum of A and B. So let's see the next question. Consider the binary operation star on the set 1, 2, 3, 4, 5 given by the following multiplication table. So this is the multiplication table. Compute 2 star 3 star 4 and 2 star bracket 3 star 4. And we have to check that whether these two are equal or not. So let's see the first part. What is 2 star 3 star 4? So first 2 star 3. So 2 star 3 will be 1. Now 1 star 4. What is 1 star 4? Again 1. So answer is 1. Now we'll check 2 star 3 star 4. What is 3 star 4? It is 1. What is 2 star 1? It is again 1. So both are equal. Now we have to see if star is commutative. So for that we'll see if 2 1 is equal to 1 2. It is true. Similarly 3 1 1 3, they are equal. Now we can see that if we draw a line here like this, right? Here we'll get 2 1, here we'll get 1 2. So the mirror images here of the boxes in this line are actually equal if we see. Okay? This is 2 2, this is 1 and 1. Similarly, this is 1 and 1. All the mirror images are same. So therefore, A star B will be equal to B star A in this case. So yes, it will be commutative. Okay. Now let's see the third part. So the third part says compute 2 star 3 star 4 star 5. So what is 2 star 3? 2 star 3 is 1. What is 4 star 5? 4 star 5 is 1. What is 1 star 1? 1. So the answer will be 1. So it's pretty simple, right? We just have to look at the table and solve the question. Let this be a binary operation on the set 1 2 3 4 5 defined by A star B is HCF of A and B. Is the operation this same as the operation star defined in the exercise 4 above? So actually what we have to see is we have to define this star dash, this binary operation such that A star dash B is equal to HCF of A and B. So if we simply see the previous question, what is HCF of 1 and 1? It's 1. HCF of 2 and 1, 1. So for all the numbers which have 1 with them, HCF will be 1, right? HCF of 1 and 2, 1 and 3, 1 and 4, 1 and 5, all will be 1. Now HCF of 2 and 2 is 2, 3 and 3 is 3, 4 and 4 is 4, 5 and 5 is 5. Similarly, HCF of 4 and 2 is 2 because 2 is the common factor. Similarly, 2 and 4 is 2. So this exactly looks like the table for the HCF. So it is true, the statement is true that this star dash is same as the operation star defined in the previous example. So you just have to make the table. It's already made in the previous one. You can simply see from there. Let's see the next problem. Let star be the binary operation on n given by A star B is the LCM of A and B. Find 5 star 7 and 20 star 16. So let's see the first question. 5 star 7. What is 5 star 7? LCM of 5 and 7. What is that? 35. 20 star 7, 16. So we have to see the LCM of 20 and 16. So we can simply multiply 20 and 16 and divide them by HCF. What is the highest common factor between these two? 4. So 20 times 16 divided by 4. So answer will be 80. Okay. We have to see whether star is commutative or not. Pretty easy. Okay. What is A star B? LCM of A and B. What is B star A? LCM of B and A. Is there any difference? No. So therefore it is commutative, since these both are equal. Right? Now we'll see the commutative property. What is A star B star C? It is LCM of AB star C, which is LCM of A, B and C. Similarly, if we take A star B star C, this is A star LCM of B star C, sorry, LCM of B and C. Now this will be LCM of A, B, C. Okay, find the identity of star in N. Now, what is an identity? You have to see, this is a pretty typical question when we have to find the identity. Now, we have to find such an identity such that we have to find such an element that the LCM of A and that number should be equal to A. So that will be the identity in that. So what is such a number for whose LCM of A and that number is A always? So we can say 1. For the case of 1, it is always true. If we take LCM of any number with 1, it will always be equal to the number itself. So the identity is equal to 1. For which of the following elements N are invertible for the operation? So we have to see for which of the elements of N it is invertible. So what do we mean by invertible? LCM of a number, okay, and some other number E is equal to 1. So when is it this true, that the LCM of two numbers is equal to 1? When is this statement true? When A and E are both equal to 1. So for which element is this true? This is only true for the element 1. And what is the identity of star? This is also 1. Moving on to the next question. Is star defined on the set 1, 2, 3, 4, 5 by A star B is the LCM of A and B? Is this a binary operation? So we'll just take one example, 2 star 5. So what is the LCM of 2 and 5? This is equal to 10. Now this does not belong to the set. Therefore this is not a binary operation. So it's just as simple as that. You just have to see whether this is lying in the set or not. If this is lying in the set, then all okay. Otherwise, it's not okay. So you can just take one example. Even if one example does not belong to this set, then this is not true for all the cases. Let's start with the binary operation defined by A star B is HCF of A and B. Is star commutative? Is star associative? Does there exist any identity for this? So this is a pretty typical question, right? It will be commutative, it will be associative, okay? And we have to see whether it will have any identity or not. So A star B is equal to B star A. It's very simple to see HCF of A and B and HCF of B and A, they are same things. Similarly, like in the case of LCM we did, A star B star C will be equal to A star B star C. So it will satisfy both these properties. And does there exist any identity? So we have to see such a number such that highest common factor in each of these cases, in all of the cases between A and E will be equal to A. So there does not exist any such number E, any such constant number E which can exist as an identity for this binary operation. Let's see the next one. For which of the binary operation are commutative and which are associative? So simply see the first case, 1 star 2, 2 star 1. They both are different, so it will not be commutative. Okay. So it's pretty simple to see in all these cases, and similarly you can see that 1 star 2 star 3 is not equal to 1 star 2 star 3. Therefore, it will not be commutative, it will not be associative. But in this case, we have to see it will be pretty different. What is A star B? A square plus B square. What is B star A? B square plus A square. So both are equal. Therefore, this will be commutative for sure. But what is A star B star C? So this is equal to A square plus B square square plus C square. And what is A star B star C? This is equal to A square plus B square plus C square whole square. So these two are different, therefore this will not be associative. So this is commutative, but this is not associative. Now let's see the next problem, third one. A star B is equal to A plus AB. So what is 1 star 2? 1 plus 2. And what is 2 star 1? 2 plus 2. So therefore, this is not commutative. Similarly, if you see 1 star 2 star 3, 2 star and putting brackets in different ways, it will not be commutative, associative as well. Next, let's see A star B, this. So if we have A star B, this is A minus B whole square. If we see B star A, it will be B minus A whole square, which is also equal to A minus B whole square. So this will satisfy the commutative property for sure. Let's see for associative property. 1 star 2 star 3. What is this value? This is 1 minus 2 whole square, which is 1. Now let's see 1 star 3. 1 minus 3 whole square, 4. 1 star 2 star 3. This is 1 star. What is this? 2 minus 3 whole square, which is 1 square, 1. What is 1 star 1? 0. So this is not associative. So this will be commutative, but this will not be associative. Okay. Let's move on to this one. What is B star A in this one? BA by 4. Both are equal, so it will be commutative. Now let's see associative property. A star B star C. This is equal to AB by 4 times C divided by 4 ABC by 16. What is A star B star C? A times BC by 4 by 4, ABC by 16. So both are equal, therefore this will be associative. Next is A star B is AB square. Okay. So for sixth, first C, A star B, this is AB square. What is B star A? This is BA square. So these are not equal, so therefore this is not commutative. Let's see the associative property. 1 star 2 star 3. What is this? 1 times 2 square, which is 4. 4 star 3. What is this? 4 times 3 square, which is 36. Now we take 1 star 2 star 3. Okay. So this is 2 times 3 square, which is 2 times 3 square, which is 18. Now we have 1 times 18, which is 1 times 18 square, 324. So therefore this is not associative. Okay. Not commutative, not associative. Moving on to the next problem. For which of the operations given above has an identity? Now, it's very typical to see when, in which case we will get an identity. So, what is the condition for identity, first of all? The condition for identity is that A this is not the question we were looking for actually. Just a second. We have to see such a number A star E such that A star E is equal to A is equal to E star A. This does not exist for all the cases, since if you put 0 here, okay, what is A minus B? This is A. If you put E is equal to 0, if you put E0 here, you will get minus A. So this is not true. Okay. So identity will not exist in any of the cases given here. Okay. So you can easily check whether this condition we can get in any case. So the answer is no. Okay. So what will we say? None of the above have an identity. Okay. So let's move on. AB star CD is A plus C, B plus D. Show that star is commutative and associative. Okay, easy. So what is AB star CD? This is A plus C, B plus D. And what is CD star AB? This is C plus A, D plus B. So both are equal. So therefore it will be commutative, right? Now let's consider 3 ordered pairs now. AB star CD star EF. First we'll start with these two. This give you A plus C, B plus D star EF. What does this give you? This give you A plus C plus E and B plus D plus F. Okay, so this is what we get from the first case. Now let's see the second one. So what is CD star EF? This is C plus E D plus F. Okay, and what is this? A plus C plus E B plus D plus F. Right? So this will be associative as well. Okay, to see whether this has any identity element or not. Okay, so what do we check for identity element? We have to see such E1 E2, okay, such that AB star such that, let's say, A1 A2 star E1 E2 is equal to A1 A2 is equal to E1 E2 star A1 A2. So will this be true for any case? No. This will be not true for any element E1 E2 which will be there. Okay. State whether the following statements are true or false. For any arbitrary binary operation star on set n, A star A is equal to A for all A belongs to n. Okay, so we'll see a binary operation A star B is equal to A plus B. Now what is A star A? This will be equal to 2A, so this will not be true, false. If star is commutative binary operation, then A star B star C is B star C, C star B star A. Okay, if you have A star B star C on this side, and here you have C star B star A. Now what is C star B? This is same as B star C, since star is commutative. What is A star B star C star A? This is same as A star B star C. Hence, proved, therefore, this will be true. Okay. So let's move on to this question. A star B is defined A cube plus B cube. A star B is A cube plus B cube. Choose the correct answer. Okay. So if you have A star B, this will be equal to B star A for sure. Okay. Since this is A cube plus B cube, this is B cube plus A cube. So this is commutative for sure. No doubt about that. Now we have to see whether this is associative or not. So this function is defined on natural numbers. So we'll take examples, or we just solve like this. What is A star B star C? This is equal to A cube plus B cube star C. This is equal to A cube plus B cube plus C cube, right? What is A star B star C? This is equal to A star B cube plus C cube. This is A cube plus B cube plus C cube whole cube. So these two are not same, therefore this is not associative. So this is commutative but not associative. B part, right? So this is mostly how we solve questions regarding binary operations, okay? In the next video, we'll discuss the miscellaneous problems of relations and functions, and stay tuned and keep watching the videos. Thank you and have a nice day.